Dia di semuanya topik kan.
Bukan ada orang cuma tapi dia harus tunjuk tau. Sebab
Orang dengan gaya lah.
dia harus faham
Layer kan.
Mungkin
Dah tahu dia presentation.
Malaysia.
Presentation ada? Oh, presentation. Presentation ada kat application. Network dengan data layer. Just transport layer. Application. Session, presentation, application.
Kita lagi ikut assignment dia. Clear? Hello. Okay, so today we will actually continue with two discussion, very quick discussion on two types of question that we haven't discussed yet, because last time we focused on the LSM, so that you can master it. Did you get your marks, coursework mark for apart from test 2 already covered? Okay, I'll remind Dr. Sudhir. I haven't completely marked the test 2 yet, quite easy. But so far, until I marked the, I think the worst, they get actually about 7.5 out of 10, the worst, okay? So mostly 7.5, 8, 8.5, 9, 9.5, 10 like that. So test 2 marks, I don't think so, it will be very bad. But I don't know about the previous marks. They already presented, they actually can share detail as them in mind. Okay, and as for the, so if I unable to complete my marking, if I cannot return the script, I'll share the solution as it is for you to especially for the DLSM. You have to look before go to the exam. If you did any mistake or anything, you can check it and then you can do better in the final exam, especially for the DLSM. Exactly the same. Very sensitive point. So as for today, we are going to look at one example.
Application.
Okay. in data communication, the data actually we call it as a packet. Each of them is a packet. It's divided into packet, right? So in transmission from one point to one point in a link, so it can suffer from various type of delay, and that delay we want to calculate. Okay. So the D stand for delay, and what the D processing is PRIC processing. I mean, I'll share this one. We need to take photo. Okay. I'll share this one. Already prepared in your what you call that. This is already in your slides anyway. And this one I will share with you later. Packet delay, yeah. This part I should share later. Then we will discuss one question based on this. Important for your final exam. Okay, so I think we have already discussed. And we have queuing delay, DQ, and transmission delay, and finally propagation delay. So there are various types of delay. And transmission delay is actually equals to N over R. R refer to the what is that? Data rate, or transmission rate, and then the L refer to the packet length. Okay. And here the D propagation equals to D over S. D refer to the total distance in the link, and then S refer to the speed. Okay. Speed. But here, if you look at the slide, there is no example based on this whatever this equation. So therefore, we're going to discuss one example today, which will be important for your final exam. So the equation given here, shown here, it won't be given in the final exam. So you have to remember the equation. Okay. Right? So let us look at one example. So this actually, we are going to calculate the packet delay. For example, let's say more packet means you will have like a more delay. Okay, very simple. So because each packet will have like certain delay based on that. Let's say it's actually the packet length actually 4 means, so you multiply it for 3 means multiply 3. So that's obviously calculated. As for the first one, you see okay, so here you see we have 5 equal size packets, and each 120 bits, 1200 bits, and these packets are transmitted through 3 store and forward links with the following distance. So we have 3 links here: link 1, link 2, and link 3. And each link has the following characteristic: transmission rate 150 megabits per second, and then propagation speed 2 times 10 power of 8 meter per second. Okay. So here, for transmission is very easy to calculate. So where you can just use the packet length 1200 divided by transmission rate, okay, 150 megabits per second. So this is referred to the L. Sorry, here. This is referred to the L. And this is referred to the R. Okay. And then propagation speed, this is referred to the S. So you have to calculate one by one, then only you can total up. So for example, this question, they ask first calculate the total queuing delay for all packets. Okay, calculate the total queuing delay for all packets. So here we have to calculate the DQ. Okay, but to calculate the DQ, you still need to calculate the what to call that transmission delay first. Transmission delay still need to be calculated. Later you add again, but before you calculate queuing, you have to calculate the transmission because DQ actually based on the transmission delay. So first you will calculate for 1 knot. Okay, for the DQ or D transmission for 1 knot. Okay, you calculate that is D. L over the transmission term. L over R. Calculate this first. This is 1200, right? 1200 over 50 mega. How much? So in millisecond, how much? 10. So the answer is 0.00. So we have calculated the transmission, which is 0.008 millisecond or 8 times of 8 microsecond, right? So same. So then next part we have to calculate the queuing delay. So this is actually for 1 knot, you know. This is for 1 knot. Okay. This is for 1 knot also. 1 knot also implies for 1. This is also for 1. So So how many packets we have? Okay, so the formula is actually, I mean, we just take note of it, like this is actually the formula. Because later we will use, we need to remember the formula. Okay, 5, not 3. Link is actually 3. So here, n minus 1 times the D transmission, okay, for 1 knot. So this is the formula for 1 knot. N is how much? So this is actually n. This is all you have to know what refer to what. Otherwise, later when you use the formula, maybe you mix up. So here we have 5 minus times 0.0008. Zero point zero 32 millisecond. Okay, you see, they will have like a different assumption when they calculating. Okay, like some textbook they have like a different formula, so don't get confused. As for the exam, you don't have time to analyze why that formula like this and why this formula like this. You just follow me, use the formula that I teach you in the exam, you'll be successful. Don't create headache for me during marking time. Okay? Don't create headache for me, because there is other assumption also. If you use the other formula also correct, but I need to go and check back. Okay, why this formula use this formula? So it takes time for me to mark. Like in some cases you would see like n minus 1 n minus 1 over 2 times n, I think. Then it runs. So please avoid using this formula all. Some textbook they have like a different assumption. They will have a different. This is very simple one, simple calculation. And then, okay, this is actually for 1 knot. Okay, so we calculated for the 1 knot first, and then for 5 packets. Now how many links we have?
0 and
3 links. So the DQ total okay, the link, let's say we call it as an n, easier for us to do in the exam. The link, we call it as an n. Number of links. Okay, so we have 3 links. M times the what you call that, the for DQ for 1. So this will give you how much times 0.096 millisecond. Or you can calculate total directly from here. If you want to skip this one, you can directly calculate also. This retransmission is important, because we use it again in the main equation. Here you see we have retransmission here, right? So that's actually, we will use it as a separate to calculate the not totally loss, okay, for the nodal processing. Okay. So this is, we just finished part 1. Very nice students, huh? Balik tak datang lagi. On loss. Yes. Yes. 1, 2, 3. Again, entah itu semua lagi. Tomorrow you have exam, right? No, tomorrow don't have exam. Next exam when? 7. Oh, yesterday you had. Oh, then after this, next week only. Oh, very long gap now. So I believe most of you already went back without bothering what I'm going to teach you today. Or Dr. Surin, right? Many of them already went back. And then they'll come back in the next semester or the following semester to repeat the subject. Okay, then this is part 1. Part 2, we are going to calculate the other delays. So now, 1 done. Q total done. And transmission total we haven't done yet. Just now we had 0.08, right? So we need to multiply with 3 now. Sorry, not 3. For 5 packets, 5. So retransmission total. So we go one by one, Retransmission total equals to n times retransmission for 1 packet. Okay. So how much here? 5, right? 5 times 0.08. 5 times, which means this is for 1 packet. 3 means we also 3 times it what called the M. M also will be the rate, right? Okay. M times it N. One packet. So M is 3, 5 times 0.12 millisecond. So this is actually for the retransmission total. Sun comes from where? This is actually LOR. Just don't do mistake where I worry you do this mistake. You calculate this one, then only you calculate the DQ. Don't do one. This is for 1 packet. And this is for 5 packets actually. This is not for 1. Or N packets, better N packets. Because the N could be different, right? For N packet. Okay. So this is for 1 packet. This is for N packet. Like we have a 5 packet, right? So 5 minus 1 here. And the Q total, Q times the number of days. Okay, and the transmission total m times n times for this actually for one packet. So you have to take the L over R only here. Or if you don't want to do any mistake, you write like this m times n times L over R. This is total. But here you use only for one packet. Don't get confused. Huh? So this is actually for transmission done and propagation. The propagation, how much the total distance? You can do one by one. 15 divided by 2 times 10 power of 8, and then 25 divided by this, and 10 kilometer divided by this. You can do one by one, or you can just add them together because all link have the same propagation speed. If the link actually, each link actually have like a different propagation speed, then you can calculate separately. But since all of them actually having the same speed, you can just add them together. Much more 15, 25. This is actually follow this formula, you know, propagation distance over the speed. Since all of them actually same distance, 15, 25 and 10, 15, 25 and 10 kilometer divided by 2 times 10 power of 8, right? Into per second. How much this? Easy. Time, fine. I got 2.5. Seconds. So 0.25, right? In milliseconds, 0.25, right? So this is for one link. Total, only total, because this is only total, right? Yeah, because we already calculated for all of them each day. So total. Now the processing. Okay, the formula, I just write the formula again so that you I use the full word because I don't want to get confused for delay and this speed. The last one actually be processing. processing delay, they already give that if the processing delay at each intermediate node is 0.8, they already give. So you have to calculate based on that 0.8. So you have 3 links, correct? So here you see they say that between each node actually, what is that? 0.8. So we have 3 links means 2 processing delay between. Or if you don't want to understand the concept, just use the formula minus 1 times 0.8 is total. They already give for 1 link between 1. They already give. This is processing delay. Intermediate node is 0.8 millisecond. So here we have how much I have? 3, right? So 3 minus 1 times 0.8, we have 1.6, right? So finally you will add all of them. Okay, be in order. You add this part 2, 0.12, right? So if we start with follow the equation 1.6 plus 1.6 processing, then queuing delay. Queuing delay, how much total just now we calculated? 0.096. This is from the part 1, 0.0096. Then transmission delay and propagation delay. Transmission delay 0.12. Propagation delay 2.5. How much is the total? 2.66. Any question on this one? I think this is pretty straightforward. Okay, this is one part. So, as for the practice, if you want to practice, just add the link, correct? Add one more link, and then you can change the number of packets and also the n value, m value. So this is all actually you can play around if you want to practice. So I can make I make it simple, you just practice with this one. If I want to test you, I actually can the propagation speed for each link I can change, or then I also can change the what is that, the transmission rate for each link. So but I don't want to do that. Actually, if you want to make it more challenging, this thing. Okay, the processing delay each node from link 1 to link 2 I can change, and link 2 to link 3 I can change. That would be more practical, no? Okay, but here we make it like a simple, straightforward question. Okay, this is one part, and one more part is actually basic bandwidth calculation, but I still worry that maybe you not aware of this one. So you see, yeah, for example, let's say we have a company or any network, the network actually support to certain number of users, and each user generating average data rate of 3 megabits per second. Just focus on here. Okay, you don't need to bother about the QoS first. QoS buffer. Okay. So how much the total bandwidth required for 120 here? You don't go for the QoS first. How to calculate? Even though this is actually basic, I need to create awareness before go to the final exam. Because when you go to final exam, anything is not taught in the class, you'll get panic, correct or not? How to calculate this one? Total bandwidth for 120 users. Total bandwidth for 120 users. From here. Don't go to the QoS all. Just stop here. For 120 users, how much the total bandwidth will be required? 120 times 3 megabits per second. Okay, only one can answer. The rest get panic. Panic attack. Morning panic attack. Okay, so if you don't want to bother about the QoS means quality of service. This quality of service buffer means to ensure what to call each user have a perfect QoS, I mean better service. Like average data rate 3 megabits per second, right? But they will give like an additional 25% so that let's say suddenly they require like more than 3, they have some additional bandwidth there. So that's actually the QoS, but QoS means quality of service per second. But this is still basically you calculate at this 120 times 3 megabits per second. So how much? 360, right? Megabits per second. Okay. If you consider this 25%, okay, if you consider the 25%, say 120 times 3 megabits per second times 0.25, how much you get? I'm just calculating the additional bandwidth. 90. Okay, so how much you have here? Total around 450. Yeah, total. Okay, this is actually minimum. This is minimum requirement. Okay, which means let's say you want to create a link, you can use the what is that? The total data rate actually up to 1 gigabits per second you can go now if you really want to have a smooth transmission. But it's actually the minimum transmission. If you really want to have a smooth transmission, you can go up to this actually minimum, so you can go above this. So let's say 1 gigabits per second is actually more than enough. Okay. You also can calculate 120 times 3 times 1.25. Also you'll get directly the 150. Okay, that's all my discussion. Straight to the point. You have any question? This is simple, but I don't want you to get confused doing the exam. This is packet delay, binary calculation. All we have in the exam, and then you have to complete all the tutorial 1, 2, 3, 4. I haven't give the solution yet, right? So I later share the solution. I have the solution. So 1, 2, 3, 4, you all have to do. I think 3, 4, 5, 6, 7 you have done before, right? I think VLSM I believe you can do, because I see most of you doing the test. You did well for the VLSM. Okay, almost more than 90% you did well. Maybe you did like a slight mistake there. I asked something else, you give something else. You miss something else. You miss what I want to really want to ask. I mean, wanted to know that, but you missed. But the process, the calculation, all actually done well for VLSM. So I don't think so you face issue. I don't know about the other two lecturers' question. Okay. But as for my question, 2 questions, you have a 2. I forgot now. 2. 5 and 6 is my question. Sorry, yeah. I have to open the question. Dangerous, all I know. You will wait for my careless mistake. Last time, one lecturer only opened shortly, straight away take photo. Oh, mine actually 4 questions, sorry. Sorry, 4 questions, 3 questions, sorry. Question number 4 is actually mine, VLSM. Subnet, this is all the IP address subnet, question number 4. And then question number 5 and 6 is actually mine. So question number 5 and 6, whatever things that I discuss here and also in my classes and also in the tutorial, you have to do that enough. Okay? I won't go beyond that. Even with that also, I don't know whether you can score or not. I mean, majority can score. This is all design question. You see the design, you won't see the design question like what we see in electronic or network. The design means you will create the topology. That's actually one part of design, correct? And then you create the what they call that network system with the IP addressing subnet mask. This is all like a design question. Okay. So this is all my part now. Whatever things that I discuss in the design question, like create a topology for what they call that. If you see one example in the slide, also in our tutorial for emailing system, okay, using the POP and IMAP. So this is all actually we illustrate, we describe how it works. This kind of design question you have in the computer network. You won't see like a design question like what you see in electronic or the subject. Like EM, we will have like a pure electronic. I mean EM, EIM, we have like a amplifier, sensor, then go to the ADC, DAC, right? You won't see that kind of design question in computer network. It's more on designing the network using the topology. Okay, like what you see in the question 1 and 2, right? So like that. And also VLSM. VLSM for me is actually considered design question because you actually given a situation scenario where this is actually the what they call the IP address, and you need to create for this amount of 3 department. Each department, this is the size. So this is actually design question for me because you create by yourself, right? So 4, 5, 6 actually my question. 4, 5, 6 my question. I believe you can do. You have any question? You have any question before we leave? Mine actually very quick, fast and furious. Okay, so prepare well for your final exam. Okay, don't for my part, if you don't do the finish the class today, and also if you don't do the tutorial, you won't do well for some. If you are here and already done the tutorial, it's sufficient for migration. Just that you need to remember, you don't forget the formula and also for the IT. So a lot of things you need to remember during the migration. That actually be your challenge. Okay, you can leave if there is any no question. So next exam 7.